Okay, today we're going to look at particles called ions. Okay, ions are charged particles and they are formed during chemical reactions, and in particular the chemical reactions between a metal and a non-metal. Now they are charged because they're formed by the loss or gain of electrons, and that leads to an imbalance in the number of protons compared with electrons. Remember, atoms are neutral because they have an equal number of protons and electrons, but for ions that's not the case. So what I want you to do is watch the Fuse School video. Okay, there's a link to it in Classroom, and I want you to use that video to make sure that you can answer all of the questions listed here. You can read them as well as I can. Okay, so two types of ions, how are they both formed, why are they charged, which type of element forms the two different types of ions, what do all ions have in common in terms of their electron arrangement, and then I want you to draw diagrams to show how ions are formed for sodium, magnesium, aluminium, the chloride ion and the oxide ion. What I want you to do is use the circle sort of diagrams that you learnt last week. So you draw out sodium 2, 8, 1. So 2 in the first shell, 8 in the second shell, 1 in the third shell. Then put a little arrow and then you draw the sodium ion. Key things to get right here are that the sodium ion is 2, 8. It has lost 1 electron from its outer shell. Okay, so that's a bit to get right. 2, 8 is a hint to the answer of, in terms of electron arrangement, what do all ions have in common? And then you need to put the circle diagram, saying first energy level with 2 electrons, second energy level with 8 electrons, in square brackets with a plus sign outside. You do not write 1 plus, just plus. Okay, so have a go at that for those 5 ions. And then I want you to work out whether there is a link between the charge on an ion and its position in the periodic table. The answer is obviously yes. But what can you spot? Which group is sodium in? What type of ion does it form? Which group is magnesium in? What type of ion does it form? And so on. So is there a link between the charge on an ion and its position in the periodic table? Yes, but sort of amplify on that answer, please. So spot a pattern for metals and another pattern for non-metals, please. Now, if you really want to, go and have a look at this video on the presentation, but it's not a very exciting video. And there's a clue again to one of the questions. But what I want you to do is think about what happens when sodium and chlorine react together. Okay, have a think. Start by writing yourself a word equation and a symbol equation for the reaction. And then I want you to have a think about what might happen in terms of electron arrangements. Okay, you'll have to spend some time thinking about that. So you might want to just pause the video now, because I'm then going to rattle on about what actually does happen. So what happens in terms of electrons during that chemical reaction between a metal and a non-metal? And the same sort of idea is true for all reactions between metals and non-metals. Not quite as simplistic as the sodium and chlorine, but anyway, let's have a look. So there's sodium, 281. There's a chlorine atom, 287. Now there's a certain little chemistry between the two atoms, and this results in a chemical reaction. And then what's happened? Well, let's have a look. What's happened to the electrons? Oh my goodness gracious me, what on earth has happened there? Well, look carefully. This shell doesn't have to be drawn in. I've just drawn it in so that you can see what's happened. This shell is now empty. And the electron from that shell has transferred across to the chlorine atom to form a chloride ion. Okay? Now, if that doesn't give you some hints towards some of the diagrams from earlier, well, I don't know what will. So, what have we got now? We've got a sodium ion with 11 protons, but only 10 electrons. So it has a positive charge. One more proton than electrons. Protons are positive, remember, electrons are negative. Now, what you've done is you've minused the minus, so it gives you a plus. That's another way of thinking about it. Now, for chlorine, you'll now see you've got 17 protons still, but you've now got 18 electrons, 288. And there's one more electron, so this has a negative charge. Cl minus. When you add a minus, you get a minus still. Okay, so an electron has transferred from the outer shell of the sodium atom to the outer shell of the chlorine atom. Just one electron transferred. Now you'll notice that both of these ions have filled outer shells. Oh, there's another clue to a question from earlier. They have filled outer shells, and that's the case for every single ion that's made. Now, the formula of sodium chloride, because it's made up of one sodium ion with one chloride ion, is NaCl. Okay, that's no surprise to anybody, I wouldn't think, or shouldn't be. Okay, so there is in words what happens. If you were going to have this as a GCSE question, it's worth actually 4 marks for just that little sentence. The only way you could slightly improve it would be writing maybe the sodium ion, comma Na plus, and the chloride ion, comma Cl minus. But otherwise, that is 4 marks. Well, even without those, it's 4 marks in your GCSE if you get asked that question. Okay, we know why these ions have charge. You don't need to worry about that. But this is really preparing us for later work. But what I want you to be aware of at the moment is that these ions have an opposite charge to one another, so they strongly attract each other. And that strong attraction is called an ionic bond. And as I've said already, compounds formed from ions contain a non-metal and a metal. If you've got 2 non-metals, compounds are made up from molecules, but we'll do more about that later. Now, what I want you to do, this is a bit of a challenge here, is think about, and maybe draw it out, what happens when magnesium and oxygen react, and what happens when calcium and chlorine react. Now, in both cases, there's going to be transfer of electrons, but I want you to think about how many electrons you need to transfer, and maybe have a think about, well, what's the formula of these compounds as well. Okay, that's enough of a challenge for now. And what I'm going to get you to do next lesson is I'm going to get you to learn or teach you how to work out the formula of ionic compounds. So that's enough for now. Work through this. It will take you a little while, but then there'll be a worksheet appearing on Wednesday for you to do all about deducing the formula of ionic compounds from the formula of ions.